Greetings, everyone. Today we're going to explore compound inequalities. For today's task, you're going to need this foldable that we are going to be using, made by another teacher. You'll want to fold it in half, and then you can separate it into two separate tabs. Let's go through and take a look at this foldable. In example 1, we're going to turn the sentence into a graph. So the sentence says, all real numbers that are greater than -3 and less than -2. So the key word here is and, meaning our graph needs to meet both restrictions. So greater than -3. All right, all real numbers that are greater than -3. Oops, so let me draw that on the number line. Open circle at -3 and greater than. Now I'm not going to go all the way to the right because and all real numbers that are less than 2. So I'm going to go to 2 and draw an open circle and go less than. So notice how these arrows, or my shading, if I'm shading in the middle, they would meet. They won't pass each other. So my restrictions are now that I can only utilize the numbers between those two circles. So we created a unique graph using the word and. Keep that in mind. That's going to be a visual cue as we go through this lesson. There's another one for us to try. All real numbers that are greater than or equal to -1, and I'm going to reread it, all real numbers less than 4. Okay, so I'm going to have a solid dot on -1, and I'm greater than, so that means to the right, and then less than 4, that means open on 4 and going left. So I can see that they meet in the middle. Again, with the word and, they're meeting in the middle, okay? That should continue to happen. Let's jump to the other side of our foldable where it says the word or. So this looks a little different, right? Well, let's approach it in the same way. All real numbers. All right, let's put an X for that. That are less than 0. See how I wrote that? Real numbers less than 0. Or, I'm going to reread this, all real numbers greater than or equal to 5. All right, let's try graphing this. This is going to look different, right? If I have a less than 0, that's open and going left from 0. But now look, I have a solid dot on 5 and I'm greater than 5. So this word or, now my graph's going the opposite, or opposite. There's a little O sound that might help you. Let's try it again. All real numbers that are less than or equal to -2, or all real numbers that are greater than or equal to 2. It's got that word or, so they should be going opposite. Let's double check. Solid dot on -2, less than. Solid dot on 2, greater than. I have the word or, and they're going opposite. So with that in mind, we should be able to predict what our graphs are going to look like when we solve. Now look at this inequality. You probably haven't seen one like this before. Look at how there's two inequality symbols. So when you have two inequality symbols in a big statement, that is an and inequality. Now a way to remember it is they're joined, they're together, they're and. Okay, so remember how I always say to draw a line down the symbol? You're going to keep doing that, but look at, you're going to draw the line down two symbols. So I always say what you do to one, you do to all. The difference is you've got 3 columns here, so what you do to one, you still do to all. So take a look at this X, right? I want to get x by itself, and currently it has a -5. So I got to kick the -5 to the other side. And you might be thinking, which side? All sides. See how that changes things? So I always say write it on both sides of the line. Well, you're going to write it on all 3 sides of the line, essentially. So let's calculate. -8 plus 5 is -3. The symbol falls down still. The x falls down. -2 plus 5, 3. Now, let me write this another way. You don't have to, but if I was to rewrite this, the x is less than or equal to 3. I can see that here, right? X is less than or equal to 3. And then if I write the other one, it says -3 less than x. And remember when we talk about flip-flopping, that would be like writing it this way. See how I flip-flopped it? So if I was to graph those 2 answers, that would mean a solid dot on 3 and going less than, and then an open circle on -3 and it's greater than. See how they come together? That's because this is an and inequality. And you don't even need, I don't need to tell you the word and. Here's my trick to remember. If the inequality is all together, or if the variable's in the middle, then I should have a graph in the middle. Does that make sense? That's just a visual clue. If my variable is in the middle, everything's connected, then my graph should be in the middle and everything should be connected. And we'll keep working on this. Let's try another one. It has a couple more steps. Let's draw lines down the symbols as always. Now, am I going to divide by 2 or subtract 4 first? Remember, don't call me after midnight. We want to add or subtract first. And what I do to one, I do to all. That takes on a new meaning. Lastly, we want to divide by 2. What I do to one, I do to all. See how that happens? The x falls down, the symbols fall down, and we have our answer. Now, you do not need to rewrite this, okay? We know this is an and. So we know, this is a shortcut now, okay? I'm saying that x is less than or equal to 10, and x is greater than or equal to 3 if I read it from the x side. But the sort of shortcut way would be if this is an and, they're going to meet in the middle every time. Every time it's an and inequality. All right, let's flip to the other side of the foldable. Now you can see the word or. See this word or in here? Or means they're going to be opposite. And or is going to be your friend. It's going to be the easier option because look, it's 2 completely separate inequalities. So you're going to solve them completely separate. It's almost like you're doing 2 problems and then you just happen to be putting them on the same graph. So we're going to follow these easy steps like you've always done. X is less than 3. Okay, open on 3 going left. If you need help understanding why it's open and the direction, you need to see our 1- and 2-step inequality video. Let's take a look at the second inequality. I'm going to add 6. The -3x falls down. I've got a -18. I'm dividing by a -3. Oop, stop there. I just divided by a negative. Divide by a negative. What does that mean? Need to flip the sign, right? If you don't remember why, see the previous videos, okay? So the x falls down, and I now have a -6 on the right. So that means open on -6, and I want to be greater. Perfect. This is an or inequality, and they're going opposite directions. That will happen every time if it's an or. Let's try another one. So again, I'm going to draw a line down the symbols that says or, so they're completely separate problems. It's this one or this one. So I'm just going to follow basic solving. Divide by 4, nice easy calculations, right? We don't deal with anything too crazy on our graphs. We're going less than or equal to. All right, on to the next. Yes, I'm going fast through solving these because the solving part isn't what's new here. What's new here is the idea of having two things on one graph. So greater than 4, open to the right. It's or, and they're going opposite. That's good. A couple additional examples I wanted to address. These are not in your foldables, so I do recommend jotting these down on your notes sheet. We've got a combined inequality, which means I need 2 lines. And this is unique because instead of timesing by -6, we're going to divide everything by -6. Now keep in mind, we just divided by a negative. When we divide by a negative, we flip the sign. Now, here's what's unique. We're flipping 2 signs. Okay, so that is a little different. If you flip 1, you flip all if there's more than 1, okay? So let's see, a -3 divided by a -6. That's actually a positive 1/2. We need to work on that. A negative divided by negative is positive. 3/6 is 1/2. The m falls down. 6 divided by -6 is -1. So on my number line, I'm just going to do the basic numbers here. We're going to have an open circle on -1, and a closed circle on a half. So kind of look where a half would be and just put a closed up. You don't, I mean, you could label it. You almost don't even need to, though. This is an and. I know it's an and because it's all together. So my graph, if I'm shading or drawing, is going to meet in the middle. Okay, now if that's hard for you to see, if that makes sense, jump to the next slide. But if you're still struggling with what that looks like, then let me rewrite this. Okay, if I write 2 m statements, okay, I'm splitting this up. The first one, I'm pointing to the m, and I've got a half. See how I rewrote that? I flip-flopped it. And then let's look at the second part. The m is greater than, and then a -1. If you need to write it separate, look, that would mean I'm less than or equal to 1/2, and I'm greater than -1. If I write them separate, you might be able to read it easier to understand why it comes together. Now, occasionally, again, this is an additional example for your notebook. Occasionally, you might be given the word and. So how does this change things? To be honest, it just makes it easier to solve. You're going to have 2 separate inequalities, but knowing it's an and tells you it's going to meet in the middle. So I'm going to approach this by just solving the way we've solved all of our other problems. I've got y, 2/3, that's okay. Let's deal with it. I'm going to solve the next one. Plus 4, 18, divide by 3, 6. Okay, so on my number line here, I'm going to, let's see, I'm going to go 0, 1, 2, 3, 4. I'm going to go by 2s, I guess. Right? You can graph however you want because you're making your own graph, right? But I need a 6 for this blue one, right? And I know it's going to be less than 6, so I'm going left, right? Now I'm going to flip-flop this other one. Remember how we flip-flop? Flip the letter, the number, and the symbol. We only do that to write it the correct way with the variable first. So 2/3 would be somewhere in here, right? Just before 1. And then it's greater than. Oh, greater than goes to the right. Hey, they're meeting in the middle. Perfect. It's supposed to meet in the middle because there was the word and. So it's pretty rare we'll write the word and. Typically, the problem will be all written together with the 3 columns. Okay, but I wanted to show you that this is an option. All right, one last example for your notes here. Now this one I wanted to provide an example of because some of you still need that practice of what to do when there's a big fraction bar. If there's a big fraction bar, it's in the way. Instead of divide by 9, we need to times by 9. And what I do to one side, I do to all 3 because I have 3 sides. So a -27 symbol falls down. 6 minus q, 3 times 9. Oops, sorry, my writing's bad there. 27. Oh my goodness. Let me try this again. It's really bad. 27. All right, next, add or subtract. Now we're following the traditional solving rules. Remember that big fraction bar was unique. Instead of positive 6, I'm going to minus 6. So negative 33, symbols fall down. Now, look at what falls down in the middle, a negative q. So technically, what number's in front of that q? A negative 1. Don't forget that negative. That matters because now I'm going to divide all 3 sides by negative 1. I just divided everything by a negative. See how I'm highlighting that? That means I've got flips to do. So let's see. Negative 33 divided by negative 1 is 33. I'm going to flip both sets of signs. The q falls down, and 21 divided by negative 1 is negative 21. Okay, see how that worked out? Now it's all flipped around. So when I go to graph this, I've got a large spread of numbers there. So I'm actually going to cheat a little bit on this graph, and I'm not going to make it symmetrical. I know I'm going to have solid dots on both of these values. And before you read into this or think any more than you need to be honest, this is an and inequality. So what kind of graph does it have to be? It has to come together in the middle. All and inequalities will do that. So if we read it more formally, if you don't understand that, I'm saying q is greater than or equal to negative 21. So I got to go to the right. I'm saying q is less than or equal to 33. I got to go to the left. If you need to rewrite it, that's an option. But if you know it's an and, you know it meets in the middle. I'm going to show this one really quick. It's up to you if you want to write it down. You don't need to. But I'm just going to quickly show a quick OR inequality. Now notice what's happening. I divided one of them by a negative. So this one flips its sign because we divided by a negative. So with the OR inequalities, you may flip only one sign, and that's okay. So in this case, I am less than negative 3, greater than or equal to negative 2. A true OR inequality because it goes opposite. Now, a couple of things we need to remember. All and inequalities will come together. All or inequalities will go apart every single time. Do you notice that we didn't get any graphs that went the same direction? That will never happen. If you graph something like that, you've made a miscalculation or you're not remembering the rules, okay? And together or apart, they will never go the same direction, okay? So keep that in mind. As always, make sure you check Google Classroom. If you need extra help, the Sabre Center and B202, is always available for help. Check the schedule on Google Classroom. Make sure you know what your assignment or task is for practice. And until next time, have a good one.